training one advanced model can burn more energy than a small town. You're using these tools daily without seeing the environmental bill stacking behind them. The hidden trade-offs shaping this technology will completely change how you think about it. Most people think AI lives in the cloud, weightless and invisible. In reality, it runs on massive physical infrastructure that consumes staggering resources. Data centers powering modern AI systems draw gigawatts of electricity, comparable to entire cities. And it's not just energy. These systems also require water for cooling and vast land for server farms. What's misunderstood is how fast this demand is accelerating. As AI models grow more powerful, their environmental footprint scales aggressively. The more you rely on AI, the more this hidden cost grows behind the scenes. And this is where the numbers get uncomfortable. Training a single large AI model can emit as much carbon as hundreds of transatlantic flights. That's because training requires running thousands of GPUs continuously for weeks. Each chip consumes high power, and when scaled across clusters, the demand becomes enormous. Cooling systems then multiply that energy usage further. The key insight is this: efficiency improvements are not keeping up with model growth. Even though chips are getting better, the size of models is expanding faster. This creates a net increase in total emissions. And the environmental cost doesn't stop after training. One widely discussed case revealed that AI data centers can consume millions of liters of water daily. Facilities in regions like the United States and parts of Asia use water-intensive cooling systems to prevent overheating. In some areas, this has raised concerns about local water shortages. For example, during peak training periods, a single cluster can require continuous water circulation equivalent to thousands of households. The impact becomes more visible when these centers are placed in already resource-stressed regions. And the land footprint adds another layer to this story. You can actually reduce your personal AI footprint with a few simple choices. First, use AI tools more efficiently instead of running repetitive prompts unnecessarily. Each query may feel small, but scaled across millions of users, it compounds fast. Second, choose platforms that publicly commit to renewable energy or sustainable data centers. Some major providers are shifting toward cleaner energy sources. Third, avoid overusing heavy tasks like large image generation when lighter alternatives work. These small decisions matter more than you think. But the bigger challenge is what happens at industry scale. The biggest risk isn't today's impact, it's exponential growth. As companies race to build more advanced models, the demand for compute is exploding. That means more data centers, more land usage, and more strain on power grids. Some projections suggest AI could consume a significant share of global electricity within the next decade if trends continue. The tension between innovation and sustainability is becoming impossible to ignore. And the next phase of AI development may depend on solving this exact problem. The future of AI will be defined by efficiency breakthroughs, not just intelligence gains. Researchers are now focusing on smaller, more optimized models that deliver similar performance with fewer resources. Techniques like model compression and smarter training methods are gaining traction. There is also a growing push toward building data centers in colder climates to reduce cooling needs naturally. The companies that solve this efficiency puzzle will dominate the next era of AI. And the direction they choose will shape everything that comes next. Subscribe and hit the bell if you want to stay ahead of what's coming next.